So I'm going to show you how to calculate the inverse of a few different types of functions, namely logarithms, exponential functions, and linear functions. So here's an example of a logarithm function where you're asked to solve. You're asked to solve log base 2 of 30x plus 25 equals 8. If you watched the last video, you will notice that this is one of the problems that we did. But here's the difference between solving a problem and finding the inverse is that the only difference is that the 8 is a y. Everything else is exactly the same. So the difference between solving a logarithm problem and computing an inverse is that there's really just two variables instead of one. So I'm going to show you how to do problems like this. We're not going to start with one like this challenging. So there's a couple of steps to finding the inverse. The first step is to switch the x and y value. And that's because an inverse reflects an item over the x equals y axis. It also is really just doing the function backwards. So if we switch x and y in the equation, then every piece of it switches, right? If we're thinking about this from what is an inverse, if we have a function machine and x goes into that machine, and then the function happens, and then some y value comes out, we're really just doing that process backwards. And so that what goes into a function, typically we say is an x value, so that's why we're switching the x and the y's, because the x goes in, the function does its thing backwards, and then a y value comes back out. So I hope this visual is helpful. Anyway, we're going to switch the x and the y, and then we're going to solve for the equation. So this is a linear function, and it's really important that we notice that it's a linear function. And what I mean by that is there are no exponents. So it's y equals mx plus b, and so we've got our m and our b, and those should really help us as we solve. So our step one is to switch the x and the y value. So I'm going to rewrite this. X instead of y equals 3 over 2y minus 2, and then we have to solve for y. So we would do our normal steps as though we were solving for y. So we're going to add 2 to both sides. So it's going to be x plus 2 equals 3 over 2y. And now to undo a fraction, we're going to multiply by the reciprocal. So multiply by 2 over 3. That cancels the 2's out, cancels the 3 out, but I got to do the same thing on everything on the same side. So I'm going to wrap this in parentheses so I remember that. Multiply by 2/3, because I did it. I multiplied by 2/3 over here, and I have to multiply everything by 2/3 over here. So our answer could be done, and really it depends on how your teacher wants it. We could say our answer is 2/3 x plus 2 equals y, or some teachers really like to have the exponent distributed. So if you'd like, you can distribute the exponent, and so that would be 2/3 x plus 4/3 equals y. And either one of these, if you're in my class, will do. This is a little different because it is an inverse of a logarithm, but essentially it's the same as solving. We're going to switch the x and the y first, so instead of, it's going to be x equals log base 3 of y minus 10. And then what I'm going to do is I'm going to use the property that b to the power of an exponent equals number, and that relates to log base b of the number equals the exponent. I ran off the page, sorry. So we're going to use this property to convert. So it's going to be the base to the power of the exponent, or the base of the log to the power of the answer. So 3 to the power of x equals the stuff inside, or that stuff inside the logarithm is the number. So in this case, it's going to be y minus 10. And then just add 10 to both sides. So 3 to the power of x plus 10 equals the y value, and this is your answer. The reason why we had to go from here to here is because I don't know how to get y out of this other than to change it to an exponent. In order to change it to an exponent, I needed to use this property that I have about exponents and logarithms. We're going to do another one. And the last type of problem that you'll typically see for inverses is with exponent functions. And the first step is always going to be switch the x and the y. So x equals 10 to the power of y plus 8, and then solve for y in the equation. Now I can't divide by 10, that's not going to work, but I can subtract 8. And I'm going to do PEMDAS backwards. And what I mean by that is I want to undo subtraction and addition first before I undo the exponent. And now I feel stuck. How do I get this this y out of the exponent? Well, I'm going to use that handy exponent problem, exponent to logarithm, and convert this to a logarithm. So it would be log base 10 of the answer that I had, which is x minus 8, equals y. Knowing the base to the power of the exponent equals a number is comparable to log b of the number equals equals the exponent. You have to know this. This is something that you can have it on a sheet of paper to remind yourself, but in order to solve logarithms, you really do need to know that piece of information. So you might want to pause the video, or if you're really unsure, you can watch along as I go. But pause the video and try these on your own, and see what you can do. Remember to switch the x and the y, and solve for the y in the equation. I'm going to write that property again. Base to the exponent equals the number is the same as log base b of the number equals the exponent. And we're going to practice with these three. So I want to switch the x and the y. X equals log 6 of y plus 7. And then I'm going to convert. So I've got 6 to the power of x equals y plus 7, and I'm solving for y. So subtract 7 from both sides. So it's 6 to the power of x minus 7 equals y. And that's your answer. That's your inverse function. Right, here we've got a exponential function, so we're probably going to do the same thing but with a logarithm. I'm going to just switch the x and the y. So x equals 2 to the power of y plus 3. I'm going to take 3 away from both sides because I'm going to try and do PEMDAS backwards as best I can. X minus 3, because I have to undo addition before I undo the exponent, 2 to the power of y. I'll write that nicer. 2 to the power of y. And then I'm going to use my property. Well, I've got a base and I've got an exponent, so log base 2 of the answer equals y. And this time it popped right out. So this is your inverse function because we solved for y. All right, this last one, it's a linear function. It might not look like a linear function, but it is because there's no exponents and there's no logarithm. And so, again, my first step is to switch the x and the y. So x equals 5y minus 15 divided by 7. To undo this, I'm going to multiply both sides by 7 because I have to undo division first. It's the biggest thing, and right now I don't have anything, so I'm going to multiply by 7. So 7x equals 5y minus 15. And then I'm going to add 15, and this is now just a linear function. So 7x plus 15 equals 5y, and we're not done yet because we have to 7x plus 15 equals 5y. We have to divide by 5. Divide everything by 5. So 7x plus 15 over 5 equals, the 5's cancel out, y. All right, here are some more problems. Instead of walking you step by step through them, I will just have them appear at the end of the video. But please remember that when you're solving these problems to switch x and the y, and then you're solving for the y value. And with a logarithm base 10, without a base, it's by default base 10. Hopefully you already knew that. So I'll give you about 5 seconds, and then I will display the answers.